session will have presentations on latest technologies and innovations, case studies, and products by the most prominent technical partners in the industry. So let me invite the very first presenter for this session. May I invite Mr. Alessandro Ederlini, Head of Photovoltaic Division, CovMe. Please join us, sir, and the topic is going to be Backsheet Solutions for Bifacial PV.
Thanks to the audience for being here. I would like to introduce CovMe and myself. I'm responsible for the solar division in CovMe. We are experts in front sheet and backsheet. The topic for today is backsheet solution for bifacial PV. So we will focus the presentation to bifacial PV and the backsheet that should be utilized for this scope. And we will also discuss about a couple of case studies where we'll introduce tests on PV modules using transparent and white backsheet. That's a brief introduction of our company. It's a privately owned company based in Italy with headquarters in Bologna, my hometown. We have 2 production sites in Italy and in China, and 3 R&D labs, Italy, China, and Germany. We have more than 60 years in know-how in converting polyester film. Say we deal around 18 tons of polyester films per year in several different applications. We have commercial offices all around the world and also warehouses where we can serve the market locally, including India. We have around 300 and more employees and 130 million euro turnover. The expertise of CovMe is based on different businesses and machinery. We laminate mainly polyester film, aluminum, copper, special papers for different applications. One of these particular applications is solar backsheet. But we also have other businesses like electrical insulation, industrial films, films for printing, and also several industrial applications also in the furniture business. We can apply coating on the film. We are able to apply coating on solvent-based and water-based and also UV curable coating. We have in E-beam and UV technology to apply a very strong coating. We are able to treat the film in order to increase the wet tension of the film by mechanical and chemical etching. So basically the surface of the film can increase the wet tension and can double it from a standard PET film, which is around 38 dyne per centimeter. We are able to increase it to nearly 60. And this will help in several applications in order to make the film more bondable. We also able to heat stabilize the film down to even 0.2, 0.3%. These are the different applications. We, as I said, specialized in photovoltaics, which accounts for more than 40% of our revenue. We also have several applications in film division, electrical insulation, and furniture, where we provide the substrate in the automotive industry, biotechnologies, in biomedical, consumer electronic, and furniture. Let's focus on PV. We've been pioneering in this market for what concerns backsheet and front sheet. We are in the industry for more than 25 years. Let's say we started in 1999. The market was really small at that time, and it was in Europe. And then everything shifts gradually to Asia. But we are operating still in several markets, including US, Europe, Middle East, India, and China. We have a current capacity of 10 giga per each production site. So total capacity is 20 giga. And all our products are PFAS-free and fluorinated-free. So we mainly use material without fluoropolymer. We can, of course, offer also fluorinated if required, but the main expertise we have, it is in polyester film, so PFAS and fluorinated-free. And we have a history, a long history. We have more than 65 giga, the equivalent of PV module power output installed into the market with our backsheet, with any known failure for more than 25 years. We started in India 15 years ago. The market was really small at that time. Coveme was already known and started to gain a lot of market, and we were one of the first to be introduced as a backsheet in India. Let's focus on our product line, mainly for transparent, for bifacial PV. This is our target of this presentation. We offer several solutions, 1,000, 1,000 volt DC, and also 1,000. So we have a couple of different structures, thinner or thicker. And this transparent film is basically made out of a special PET outer layer, UV resistance, and hydrolysis resistance stable. An inner layer, PET, hydrolysis resistant and electrical grade, and a primer or a coating to bond with the encapsulant. We can provide also grid, mesh grid, white or black. And recently we developed this grid to be highly reflective, so you can increase the output of your module. These backsheets are designed for PERC, but also recently we introduced a version for TOPCon and heterojunction. And later we discuss also about the case study we recently obtained by a very known institute called Fraunhofer ISE. As I said, we develop a special backsheet designed for TOPCon. TOPCon are more sensitive to humidity. For this reason, the market with TOPCon started with glass at the very beginning in China. We are discussing with producer, EPC, and there are a lot of issues in the market with glass, especially because glass PV module are using 2 millimeter glass or even less. And 2 millimeter glass, as you know, is not fully tempered. It's heat strengthened, so it is prone to break, especially in those areas where there is a high hail impact. So what could be the solution? The solution is to come back to the original structure, having a 3.2 millimeter glass and a backsheet. But the backsheet needs to be more water barrier resistance. You need to protect the module for moisture. For this reason, we develop a material backsheet, 1500 volt, with increased primer and a blend combination of primers that provides additional barrier. We were able to reduce by factor 4 the barrier for the water ingress from the backsheet. So at the moment, we are able to offer this backsheet, which is normally in the range of 2 grams per square meter per day. We reduce it to 0.5. Again, for those using heterojunction or thin film, we have this material already for quite a while with an aluminum backsheet. And this is cut down the moisture down to 0, let's say 10 to -3. Few words about glass versus glass backsheet. As I said, we are observing, and now there are coming more and more cases where PV plants, say in US, in Europe, maybe less in India, but where there is a high probability of impact with hail, where the PV modules are broken, completely destroyed. And imagine the cost for the investor, and the premium price of the insurance company is going up. In fact, the 2 plus 2 millimeter or even less is not fully tempered, it heat strengthened. Again, this is one major topic. The suggestion is to come back to the original version, so 3.2 millimeter glass, or if you want, you can do 2.8, but then the module becomes very heavy. So the suggestion is to use glass backsheet, where you keep a very light module, a module that can dissipate the heat, because with glass backsheet you are able to dissipate the heat and increase the yield, production of energy. We experience also several other advantages that you might have experienced, the producer of module might have experienced. And the throughput with glass is 30% less. There are a lot of breakage, there is a lot of waste, and there are a lot of issues that you have to face, not to mention the economical part of it. We calculated around 30% cost reduction by using a backsheet rather than a back glass. Why that? Is due to the lower bill of materials, not only comparing the pure glass with the backsheet, but also considering the all associated cost, the warehouse costing of stocking glass rather than stocking many square meters of backsheet. The production waste, and also the fact that you need to spend more time in maintenance. Improve handling also. Also the handling will be improved, and the production throughput will be higher. Having said that, I would like to introduce a case study. The case study we just received from Fraunhofer Hise. We sent 3 full-size modules. Actually, Fraunhofer Hise produced 3 full-size modules, and we sent our backsheet in this module, our transparent backsheet. The modules were produced with PERC cells. The test started a long time ago. At that time, the PERC were the only option available. The seed started more than 2 years ago. We had PERC, commercially available PERC, standard equipment, and EVA and POE. So we tested, we made aggressive testing. A dump pit test was made on one module with encapsulant EVA on both sides and one of our transparent backsheet, and it was aged for 3,000 hours. And then we did 2 modules, one with POE, and one with EVA, and our transparent backsheet. And these were aged using on a sequential test based on MAST. MAST is a module-accelerated sequential test proposed by DuPont. So we're talking about 1,000-hour dump pit, 600 cycle TC, thermal cycle, and 360 kilowatt-hour of UV. So very aggressive. What was the result? Dump pit test, after 3,000 hours, the backsheet was completely clear and without cracks. The yellow index, it is another parameter to check, was below 2, the delta E. So this is below what the human eye can see. You can see the picture here. The backsheet is completely inked out. And the most important is the measurement, the power loss after 3,000 hours was less than 1%. This was, even for Fraunhofer, an astonishing result, because you expect the IC test, 61215, where they used 1,000 volt, is considered passed when the power loss is less than 5%. So now we're talking about 3,000 dump pit, where the power loss is less than 1%. Let's see the sequential test. This is even more aggressive. Sequential test, you can see there the sequence. Dump pit 1,000 is on the right. No, you cannot see that. So it's 1,000 hour, then 90 kilowatt hour UV, thermocycling 200, 90 again, thermocycling 290, 200, and 90. So it's really aggressive. We had 2 modules, one produced with the double EVA encapsulant and our backsheet, and the other one produced with POE and POE. The EVA module developed some yellowing. The yellowing on the front side of the module. This is most likely the result of the outgassing, which happens in EVA. This is known. It's a known phenomenon. However, the backsheet remained clear for the whole duration of the test. What happened to the POE? The POE module did not exhibit any visual changes, and also here the backsheet remained clear and without cracks. The power loss after this test was in the range of 3%, with again, it is an exceptional result for such a stressing test. As I said, this test was performed with PERC. Now let's have a look at TOPCon. Preliminary test, because as I said, TOPCon just started one year ago and mostly started with glass at the beginning, but many producers are now evaluating to come back to the backsheet structure for the reason that I just mentioned. So we investigated, we managed to get some report from Tier 1 customers, and they produce some module, different combination of encapsulant, and a couple of types of our barrier film. In this case was a white, but this concept is similar also for transparent, because the water vapor transmission is the same. So what happened? They aged this module 2,000 hours in dump pit with different combination. There was a reference module made with the EVA, and our standard backsheet, the one we use also for PERC. And then we have other 4 modules made with our barrier backsheet in different combination, EVA, POE, POE, and EPE and POE. And the power loss after 2,000 hours of dump it was in the range of 1.5 to 2.9%, depending on the structure of EVA, POE, or EPE. And this is comparatively low degradation for a glass backsheet. Is considered well above the standards. Again, the backsheet remains clear and without cracks. Here is the EL image, and here is the measurement. In the measurement here, you have a standard, our standard backsheet for PERC, which lost after around 2,000 hours, lost around 4% or something, which is still not too bad. But the product in 2 different thickness, one, the LDO, it's called 150, and the LDO 110. They lost in the range a little bit more than 3%, but the better result was the one with 110 micron primer, which is the standard product that we introduced into the market and is now available. The loss is quite astonishing because we only have, after 2,000 hours, 1.5% if you use POE. If you use EVA, it's still less than 3%, and if you use EPE, POE is in the range of 2.7. So we are continuing the investigation. We send material to Fraunhofer, PV module, to do additional tests, and we are very confident this material can be a successful substitute for the backside glass. Just a few words, Coveme is committed in sustainability. All our material are PFAS-free and low carbon footprint. We made an LCI, life cycle assessment analysis, and we are able also to provide you this report as long as the test report for the other products. Feel free to come and visit us. We have a stand here, and it was a pleasure to introduce Coveme. Thanks a lot.